Hi guys, in this video I will be covering the abstract reasoning section of the UCAT and in particular covering some of the shapes which commonly come up and how you should be approaching them. So let's start. We are looking at the shape similar to the one on the screen. What we should be thinking of is arrows because we can see arrows in all of them. And what arrows usually mean is direction. So what we should be thinking of is where the arrows are pointing to, so where the arrowheads are pointing to. So in this case, it's a star. In this case, it's the outer wall, star, outer wall, star, and outer wall. And then if we look at all the shapes which are present in there, we always see a square, square, white square, black square, and a star is always there as it's either pointing to a star or not. But a triangle is not always there, a moon isn't always there, so they are both distractors. So if we think of what's happening to the black square, we soon realize that if the arrow is pointing to the star, for example in here, the square will be black, but if it's pointing away, then the square will be white. So this is our rule. We can't see anything else. We'll look at set B and see if it's the opposite in any way. So in this case, it's pointing to the star and it's white. Well, yeah, this is the opposite, but does that happen all the time? So this is again pointing to the star and this is white. So again, this is the opposite. And what about if it's pointing away? This is pointing away from the star and the square is black. So yes, this is our rule. So for set A, if arrows point to the star, square is black, and if arrows point to for set B, if arrows point to the star, then the square is white. So whenever you see arrows, think of direction. Next, so we have a lot of faces here. We have some dinosaurs, some Pac-Man. So what do we do? So as soon as you see faces, what you should be thinking of is enclosed spaces. So in this case, if we look at this shape here, we can see 1, 2, 3, 4, 5, 6, 7, 8, 9. There is 9. If we look at this one, which is a bit simpler than the other ones, that's 1, 2, 3, 4, 5. So what I'm starting to think, is it odd? Then again, 1, 2, 3, 4, 5. Okay, so by looking at 3 of them, I think it's odd. But can we find any other rules in there? So we can see that there is white and there's black colors in there. So if we look at the black ones, we can see there's 1 of them, there's 2 of them, there's 3. And if we look at the white one in this case, it's 1 and it's 2. So I found that black is odd and white is even. But is that the case with all of them? So if we look at the second one we looked at previously, so we can see there's 1 white in there and there's 1 white in there. So there's 2 whites and 3 blacks again. So I have got my rule for set A, that there's 3 black shaded areas and unshaded areas is even. And if we look at set B, so now I'll move on to set B and try to identify if they have got any differences or is it the opposite. So if I count all the blacks from set B, I can see there's 1, 2, 3, 4, 5. So I've got 5 blacks in there. And if I count the whites, I can see there's 1, 2, 3, 4 whites. So there's 4 whites and 5 blacks. Keeping that in mind, if I move to the second one, there's 1, 2, 3, 4, 5 blacks, 5 blacks, and 1, 2, 3, 4 whites. So none of them have changed. It's still 5 blacks and 4 whites. Now I'll just go for this one because it seems a bit easier. So the shape, which is the most simpler, just go for that one. So if I count this, I can see 1, 2, 3, 4 whites, but there's only 1 black. So from this, the rule I can identify is that for set A, there's always 3 black shaded areas and unshaded areas is even, and for set B, there's 4 unshaded areas and the shaded areas is always odd. So whenever you see faces, just think of enclosed spaces. Okay, so now moving on to this kind of shape. So as you can see, we in one box all the shape is the same, and in another one the shape is same as well. So for whenever you see the same kind of shapes, think of values. So you should be giving all of these boxes and all of these shapes values. So for example, if I have 12 of them, I can say that the value of the whole box will be 12, and I can say that makes triangle 1. So all of the shapes in set A will have a value of 12. So then I can look at the square, because that's the next most simplest one. So there's 2 squares, and if the box has a value of 12, so 12 divided by 2, which would give me 6. And then I can look at how can I identify, because there's 3 different types of shapes. There's circle missing now, so which is the simplest shape that I can identify. So I can use this one. I've got 4 triangles and 2 circles. So if I do 12 minus 4, which is 8, 8 divided by 2, this gives 4 as the value. And I can check this. So for example, for this, I've got 2 from the triangles and 6 from the square and 4 from the circle. This gives me a value of 12. Okay, so now I can move on to set B. Sometimes they would have all of the boxes would have a different value, but the values for the circles, the triangles and the square would be the same, but that's not the case for all of them. So just to make sure, I'm going to check them separately. So I can see that I have all circles in one of them. So what I can say is I can make circle equal to 1. So I can give different values from the first one. I can say circle is 1. I can say that the whole box is equal to 9 because we have 9 circles. So now looking at the second most simplest one, I like this one the most after the first one, and I can see there's 1 circle in there. So if I do 9 minus 1, that would give me 8. So that makes square equal to 2. And then I can try to identify the triangles, and I can see that there are 3 circles in there and 1 triangle. So that would be 9 minus 3, and 9 minus 3, that would give me 6. So this is how you would tackle a question which includes these same kind of shapes. So whenever you see same shapes in a box, think of values. Alright, so in these 2 sets we can see a lot of clocks. So when you see clock, you should be thinking of what the hands are pointing to, or what's the angle between the clocks. So the angle would be measured from either the smaller one to the bigger one, or the bigger one to the smaller one. So if I look at the bigger one to smaller one, this is obtuse, this is acute. So it's usually obtuse versus acute, but they don't match up, so it can't be that. So next, if I look at it pointing at, I can see this is pointing at 7, this is pointing at 9, this is pointing at 3, this is pointing at 1, this is pointing at 11, that's pointing at 3, that's 9, that's 1. So what if I'll soon realize that all of them are pointing to odd numbers. So I will have my rule there. So A, hands are pointing to odd numbers. If I look at B, I'll be looking for the opposite, and I see that this is pointing to 4, that's pointing to 6, that's pointing to 8, 12, 10, 2. So I have my rule for this as well, that all of the B's are pointing to even numbers. So whenever you see clocks, think of where the hands are pointing to, or what's the angle between them.